Finding the intersection of a circle and a line by substitution. Find the intersection of the circle and the given line by substitution. All right, they're telling us to use substitution here, no elimination. Did they tell us anything? No, they didn't. All right, so substitution here, just like the previous problem, we have y is equal to, and we have this over here. So everywhere we see y in the second equation, we're going to plug in 3x minus 5. So let's start off with equation 1. X squared plus y squared is equal to 5. And we have y equal to 3x minus 5. So we're going to set this y equal to 3x minus 5. X squared plus y. Y is our 3x minus 5. We're squaring that and then adding 5 to it. This one is just a tiny bit more complicated, but just because of the algebra here. We have a binomial that we're squaring. So what we actually have, I'll just write it out. X squared plus, we have 3x minus 5 times 3x minus 5. That's equal to 5. Here, we're going to distribute. So we have x squared plus 9x squared minus 15x minus 15x plus 25, and that's all equal to 5. All right, so another quadratic. So what we're going to do here is set it equal to 0. So we're going to subtract both sides by 5. Over here on the right-hand side, that's going to go to 0. But let's see, let's combine like terms. So here we have our x squareds. So that's going to be 10x squared. And here we have negative 15x minus 15x. That's going to be a negative 30x. Over here we have 25 minus 5. That's going to be plus 20 equals 0. I love that all of these are multiples of 10. So we're going to divide both sides by 10. So that's going to be an x squared minus 3x plus 2 equals 0. So we have options. We could do the quadratic formula. We could do AC method. We could simply factor. I'm going to choose to simply factor just because I think it's going to be easy numbers. So we need two numbers that multiply to a positive 2, but add to negative 3. Factors of 2 are just 1 and 2. But if we make both of them negative, it ends up working. So we have negative 1 plus, or I'm sorry, negative 1 times negative 2 gives us a positive 2. Negative 1 plus negative 2 gives us a negative 3. So it works out perfect. We have x minus 1 times x minus 2 equals 0. So nice and perfect. This entire product is equal to 0 when this is equal to 0, and also when this is equal to 0. So we have x minus 1 equals 0, and also x minus 2 equals 0. Our solution to our system of equations are going to be in these two parts where x is equal to 1 and also when x is equal to 2. So those two different places. All right, so I didn't show us our options, but we have a circle and a line. So circle, our line could intersect at just one point right here. Perfect. It could intersect at 2 points, something like this, or it could intersect at no points where they would never intersect. So here it kind of looks like we have that second option where it goes through the circle and we intersect at 2 different points like that. So we just have to figure out where those 2 points are. Let's start with finding the solution for when x is equal to 1. Let's start off with that one. You could technically plug it into either one of the equations. I'm going to plug it into this second one just because it's a little bit easier. Here, we're going to have to take the square root of both sides, and it's going to be a hassle. So let's just plug it into this one here. We have y is equal to 3x minus 5. And in this case, we have x is equal to 1. So we have y equals 3 times 1 minus 5. So 3 minus 5, negative 2. So when x is 1, y is negative 2. So that's one of our two solutions. Let's see what the other one is. So the other x that we had was x equals 2. So now we're going to solve for when x is equal to 2. Same equation. We'll say y is equal to 3x minus 5. Y is equal to 3x in this case is a positive 2. So 3 times 2 is 6 minus 5. That's 1. And so when x is 2, y is 1. And those are our two solutions. So not negative. So 1, comma, negative 2, and also 2, comma, 1. That's the solution to the system of equations. If you have any questions, please feel free to ask. Otherwise, bye.